Welcome to Glorious IAS Academy. As part of the convergent boundary, in last class we are discussing about the convergent boundary. So what do you mean by the convergent boundary? Convergent boundary nothing but two plates converge each other. The less denser plate converged into the more denser plate. So less denser plate would upthrust or fold, and more denser plate would converge into the less denser plate. So at the convergent boundary, subduction zone would be formed. At the subduction zone, the trenches would be formed. So in the last class, as part of the convergent boundary concept, we were discussing about the ocean to ocean convergence. So in this class, continent and ocean convergence or Cordilleran convergence, and as well as continent and continent convergence we would be discussing. So continent or ocean convergence, it also called as Cordilleran convergence. What do you mean by Cordilleran? Means extensive mountain systems. So as a result of convergence of the continent and ocean convergence, extensive mountain systems would be formed. So it is very important to understand the continent and ocean convergence in order to understand the formation of the Rockies, formation of the Andes and other fold mountain systems. So in the last class we were discussing about in the ocean convergence theory, various volcanic islands would be formed. Various volcanic islands like archipelago, Caribbean archipelago, Philippine archipelago, Indonesian archipelago, and formation of the Japanese islands. These are the islands would be formed because of the oceanic plate and oceanic plate convergence. So instead of the volcanic islands, here in the continent and ocean convergence, the mountain systems would be formed. Extensive mountain systems would be formed. It is very similar to the convergence of the ocean to ocean, but instead of the volcanic islands, the mountains would be formed. So when oceanic and continental plates are collide each other, the convergence of the oceanic plate means ocean plate is more denser and continental plate is less denser. So when oceanic plate and continental plate would converge, the oceanic plate would subduct into the continental plate, so leading to the formation of the fold mountains. For example, Rockies is one of the fold mountain and Andes is the another fold mountains. So here it is also called Cordilleran convergence because of the extensive mountain systems. So they, for example, North America and South American are called Cordilleras. So Andes and Rockies are called Cordilleras. Why? Because they are the extensive mountain systems. Next one, the trenches would be formed here not as deep as those formed in the oceans and ocean convergence. And both the convergence trenches would be formed. Here this is trench, but it is not as deep as in case of the ocean to ocean convergence. So this is the oceanic crust and this is the continental crust. So this continental plate, this ocean plate is more denser than the continental crust plate. So this crust plate means the denser ocean plate would be subducted into the continental plate. So leading to the melting of once it reaches 100 kilometers beneath the surface, means in the asthenosphere, the entire subducted plate would be melted, and as a result low pressure would be formed. In last class we have discussed a low density would be formed, and high pressure, low density, high pressure, and after that due to the buoyant force that is offered by surrounding medium in the asthenosphere, this molten magma would erupt over the surface of the ocean crust and leading to the formation of the various volcanic arcs. These volcanic arcs came to known as mountain ranges. These volcanic arc came to known as mountain range. So here the ocean crust over millions of years, they have accumulated the lot of sediments. So ocean crust over millions of years, it accumulated the lot of sediments at the crustal margins, at the plate margins. These accumulated sediments are called accretionary wedge. These accumulated sediments at the margins of the plates can be known as accretionary wedge. So this accretionary, due to the further movement of the oceanic plate or continental upthrust over the ocean plate, this accretionary wedge, that means sediments are further compressed and leading to the formation of the fold mountain systems. So for example, Rockies are one fold mountains and Andes are fold mountains, and they are available across the coastal areas of the western coastal areas of the Southern American as well as the North American continents, South American and North American continents. And next one, the formation of the continental arcs due to continent and convergence. So in the ocean plate convergence, volcanic arcs would be formed, but here island arc would be formed, but instead of island arcs, here continental arc would be formed. Because of the buoyant force offered by the surrounding medium. So there is a chain of volcanic mountains would be formed along the continental margins due to the volcanic eruptions. A chain of volcanic mountains would be formed. This, for example, this Cascade Range is one of the best example for the fold mountains. So Cascade Range as well as the Cascade Range, one of the best example. It is parallel to the Rockies. It is parallel to the Rockies in the North American continent, and Western Chile Range is another example for the chain of volcanic mountains that is formed due to the compression of the sediments across the plate margins. So it is parallel to the Andes. So accretionary wedge, we are discussing. Accretionary wedge is compressed into the continental margin and leading to the crustal shortening. This crustal shortening is compensated by the crustal widening in various areas. And what is the concept of here? When ocean crust is subducted into the continental crust, after reaching the 100 kilometers, this ocean plate would be melted, and because of the buoyant force offered by the surrounding medium, because of the low density, high pressure, this magma slowly erupt over the surface of the earth along the plate boundaries, means along the subduction zone. When this continuous eruption of magma occur over millions of years, and that leading to the formation of the volcanic mountains. So when this accretionary wedge sediments that are brought by the ocean along the subduction zone, if this accretionary wedge when sediments are compressed, it is further compression would be created and leading to these folding of these existed volcanic mountains. So in that way the fold mountains would be created. And we will see and some of the examples, and this is a formation of the fold mountains that is called orogeny. Here one of the few importance, it is a process in which the section of earth crust is folded and deformed by the lateral compression and to form a mountain range. Once the mountain range, if you, for example, this is a mountain range, and once mountain range is formed, once the series of mountain ranges, these are the series of the mountain ranges, and once the mountain ranges are formed, because of lateral erosion why? Means weathering processes. These mountains undergo weathering, physical, chemical, biological weathering processes, erosional processes, transportation processes, and because of all these exogenic processes, these mountains would be shaped into the rounded structures and formation of the existed. Right now we are seeing the Himalayan mountain ranges, Alps, Atlantic means Atlas mountains, and also Andes, Rockies, and due to the erosional activity of over the millions of years, the mountains formed into the beautiful structures. So first the mountains would be formed, after that because of the erosion they formed into the present day mountains. And next one, these orogenic movements are the tectonic movements. What do you mean by tectonic movements? It is the plate movements of the earth involving the folding of sediments, faulting and metamorphism. What do you mean by metamorphism? The rocks along the subduction zone of the two continents, means convergent boundary, they would be transferred, means the minerals in the rocks would be realigned. So the rocks structure of the nature of the rocks would be changed, that is called metamorphism. So the continental margins are filled with the thick sediments brought by the continental margins filled with the thick sediments brought by the rivers, and the stress on the upthrust continental margin, the more compressive stress on the upthrust continental margin and leading to its folding, creating the mountain system, that is called orogenic belt. And this orogenic belt further leading to the folding of and into the formation of the rocks. And so first there is a movement of the tectonic movements, and after that the accretionary wedge, means the continental margins are filled with the thick sediments, that is called accretionary wedge. When this accretionary wedge is compressed and leading to the formation of a mountain belt, that is called orogenic belt. These mountain belts are further compressed and leading to the formation of the series of extensive mountain systems. They are called Rockies and Andes. So after this culmination means the climax. After the climax of the compression and due to the isostatic adjustment, present day means the denser regions will sink, lesser denser regions will rise, so which causes the ultimate exposure to the roots of the mountain. Here the mountains are created, and here isostatic adjustment means because they are eroded, the surface of the mountains are eroded because of the various weathering and erosional processes, and leading to the formation of the beautiful mountains that we are seeing now. So this is the formation of the fold mountains. Fold mountains formation happens due to the ocean and continent convergence. So the sediments that are deposited across the boundary of this convergence boundary, along the convergence boundary, these sediments called accretionary wedge. This accretionary wedge compressed, and as well as along with the melted magma, these two activities, accretionary wedge compression and as well as the volcanic eruption, both combinedly formed into the fold mountain systems. So here we are going to look into some of the examples, the formation of the Andes and Rockies. Now in the formation, how the Andes will be formed. So here if you see, this is the ocean plate, Nazca is the ocean plate, oceanic plate, and this South American plate is the continental plate. This is continental plate, and here the accretionary wedge is deposited here. This is called accretion, means sediment brought by the means that deposited along the margin of the ocean plate. Sediment deposited along the margins of the ocean plate is called accretionary wedge. That means sediments. So first of all, a trench would be formed, that is Chile and Argentina. Chile means Argentina, Peru, Chile trench. So due to the convergence of the Nazca oceanic plate and as well as the continental South American plate, first a trench would be created, that is Peru-Chile trench, and further this trench would be compressed by the accretionary wedge. So accretionary wedge would be compressed along the boundary of this plate and leading to the formation of the Andes. See, Andes are formed due to the convergence between the Nazca oceanic plate and Southern American plate, and this where Peru-Chile trench is formed due to the subduction of the Nazca plate. So Andes are a continental arc. These are the continental arc. What do you mean by continental arc? A series of a narrow belt of a narrow belt of mountain system can be known as continental arc. A narrow belt of mountain system can be known as continental arc. So it is a narrow belt of mountain system can be known as Andes, formed due to the convergence of the oceanic Nazca plate and South American plate. Both plates are convergent, leading to the formation of the Andes. So Andes are the continental arc formed due to the volcanism above the subduction zone. So once it subducted, so the melted magma would erupted around the subduction zone, along the subduction zone, leading to the formation of the continental arc. So here, if you see, the pressure offered by the accretion edge folded the volcanic mountains and rising to the formation of the mountains significantly. So folding process is still continuing and mountains are constantly rising. So one of the example, Ojos del Salado is an active volcano. Ojos del Salado is an active volcano on the Argentina-Chile border. So the height of this one 6,893 meters. So another one is Mount Concagua. This height is 6,960 meters, and these two are the active volcanoes which are situated in the Argentina-Chile border. So Andes are formed due to the Najika as well as the South American plate convergence. Next one, the formation of the Rockies. So it is due to the North American plate, due to the three important plates: North American continental plate and John D. Fuca plate, that is minor oceanic plate, and Pacific plate, this is the major oceanic plates. So here it is a North American plate, and here somewhere located John D. Fuca plate, and this is the Pacific plate. So because of these three plate convergence, and this is the oceanic plate, and this is continental plate, this is continental plate, and this is another oceanic plate. So because of the convergence of these three plates, and Rockies mountains would be formed. So here the ocean crust subducted into the continental crust, it is the very narrow, means the slope of this subduction zone is very low. So because of the low subduction zone, these Rocky mountain would be formed. So the convergence give rise to the series of parallel mountain ranges. They can be known as Rockies. So Rockies are formed at a distance from the continental margin. If you see here, they are not formed along the continental margin, and they are slightly away from the continental margin because of due to the less steep subduction. This is the less steep subduction. They are not steep like this, and this is less steep subduction. Because of this less steep subduction, these Rockies are formed just away from the continental margins. So trenching is less conspicuous as the boundary is filled with the accretionary wedge, and there are a series of fault zones that make landform different from the Andes. So Rockies and Andes formed due to the ocean plate and continental plate convergence. Next one, continent and continent convergence. Third type of the convergence is called continent and continent convergence. In this continent and continent are Himalayan convergence. So by understanding the continent and continent convergence, we can understand the formation of the Himalayas, formation of the Alps, formation of the Ural mountains and Atlas mountains. So here the subduction zone will be not go into the 40 to 50 kilometers. So here the subduction zone is only about the 40 to 50 kilometers, unlike in the ocean and ocean continent zone. So in ocean and ocean continent it is go few hundred kilometers, but here the subduction zone is very much very narrower, means that 40 to 50 kilometers. So here the continental plate, as the continental plate converges, the ocean base means the sediments. These sediments are called geoclinal and geosynclinal sediments found along the continental margins is squeezed between the two continents. Suppose this is a one continent plate, C1 continent plate 1, and here this continent plate 2, and this is subducted into this plate like this, continental plate 2. But here the water filled with the sediments. These sediments are called geosynclinal or geosynclinal sediments. These sediments were squeezed because of the continent and continental margin, continent and continent convergence, and leading to the formation of the Himalayas, Urals, Alps and Atlas mountains. So these are these geosyncline sediments are a huge silver rocks, many kilometers wide. They are thrust upon the another, forming into the huge silver rocks. They would be one plate thrust over the means go up over the another plate, another continental plate. So huge silver rocks that are laid, and they are very wide base, kilometers away, and these silver rocks are distributed a few hundred and few thousand kilometers. These silver rocks are squeezed into the forming into the fold mountains. For example, Himalayas. So here see wide range thrust upon forming into the towering mountain range. So the sediments as well as the geosyncline sediments as well as the silver rocks that are present along the continental boundaries in the continent and continent convergence, they are squeezed, and because of these compressional and tensional forces, they formed into a towering, very high mountain ranges. They are called fold mountains. For a best example is Himalayan mountain. For example, Himalayas, Alps, Urals and Appalachian mountains found in the North American continent. So here if you see the formation of the Himalayas and Tibetan plateau. How? See in the continental drift theory, we were discussing about the entire landmass, where there was a single landmass which is surrounded by a single water body. That single landmass can be known as Pangaea. The water body can be known as Panthalassa. This Pangaea divided into two, Laurasia and Gondwana land. This Laurasia, Gondwana land are separated by Tethys Sea. What do you mean by that? Tethys Sea. So this Tethys Sea is which is separated the Indian plate and from the Eurasian plate. This Tethys Sea separated the Indian plate. See, from the Gondwana, Australia, India, Africa and South American were separated. From the Laurasia, Asia, Europe and North American continent were separated. So here the Tethys Sea which is situated between the Indian plate as well as the North American means Eurasian plate, Indian plate and Eurasian plate. This Tethys Sea is brought sediments and accumulated the sediments over period of time, over the millions of years. This Tethys Sea accumulated sediments that are brought by the various number of rivers. These sediments subsequently with the movement of the Indian plate moved northwards, and because of the northward movement of the Indian plate, these sediments, suppose if you see here, this is Indian plate and this is the Eurasian plate. Here this is Tethys Sea. So the silver rocks and sediments, that is called accretionary wedge. The silver rocks and distributed wide variety in the regions means distributed over the thousands and hundreds of kilometers. Because of the northward movement of this Indian plate, this accretionary wedge, that means sediments or silver rocks, they are squeezed and formed into the fold mountains. A series of range of mountains, extensive range of mountains. For example, Himalayas consisting of three important, greater Himalayas, lesser Himalayas, like that. Himalayas are consist of three important ranges. So these ranges are formed because of the squeezing of the silver rocks that are distributed over thousands of kilometers, because of the northward movement of the Indian plate into the Eurasian plate. See here, Himalayan mountains came out of the great geosyncline called Tethys Sea. So that is uplift has been taken in the different phases over during the Permian period, means about 250 million years back ago, there was a supercontinent called known as Pangaea. So there were many rivers which were flowing into the Tethys Sea, and sediments are brought by these rivers, and these rivers are subjected to powerful compressions due to northward movement of the Indian plate. This resulting in the folding of the sediments. So often cited fact that illustrate this is the process of the means. For example, if you can, the Mount Everest is made up of the marine limestone. So limestone is squeezed between the Indian plate and Eurasian plate, formed into the Mount Everest. So next one, once the Indian plate started plunging into the Eurasian plate, this is Indian plate, and this is Eurasian plate, Indian plate. So once the Indian plate plunges into the below the Eurasian plate, these sediments were further folded and raised. This process is still continuing. Still the Himalayan mountains are rising because of the continuous northward movement of the Indian plate into the Eurasian plate. So this is after the formation of the mountains, the erosional activity take place over the mountains and leading to the change of the mountains. So the Tibetan plateau also formed due to upthrusting of the southern block of upthrusting of the southern block over the Indian plate. As a result of this upthrusting, the Tibetan plateau formed. Tibetan plateau formed because of the upthrusting, means overriding of the southern block of the Eurasian plate over the Indian plate. So that is the reason behind the formation of the Tibetan plateau. So Indo-Gangetic plain, here somewhere Indo-Gangetic plain, it was formed due to the alluvium brought by the consolidation of alluvium brought down by the various rivers. Those are originated in the Himalayan. So some of the Himalayan rivers are very older than the Himalayas itself. Why? Because they are originated before the Himalayas. So simply Himalayan fold mountains are formed due to sediments are squeezed between the Eurasian plate and the Indian plate because of the northward movement because of the collision between the North Indian plate as well as the Eurasian plate. Because of this collision, these sediments brought by the Tethys river and various other rivers, and they were squeezed and formed into the fold mountains. So this process continues over the millions of years, and series of fold mountains would be formed. They are called ranges of the Himalayas. So like that is the Himalayas are curved shape. Why this curved shape? Because of the force applied by the Eurasian plate on the Indian plate. So because of the force, the Eurasian plate is the bigger plate and Indian plate is a smaller plate. Because of the major plate applied bigger force on the minor plate, because of this major float, the bending of the Himalayas would be occurred. The bending of the Himalayan ranges had happened. So this bending is because of the extensive force that is applied by the Eurasian plate on the Indian plate. And the Himalayas are still rising. What is the evidence for this rising? These are the high precision atomic clocks. The high precision or high clarity or precision atomic clocks are still calculating that Himalayas are rising. So Himalayas are rising per year. It is rising 5 to 10 centimeters. The Himalayas ranges are rising 5 to 10 centimeters per year. So frequent volcanic activity is also tectonic activity. Frequent tectonic activity also happening because of the disturbances, because of the crustal disturbances happening beneath the surface of the earth along the Himalayan ranges. So these continuous tectonic disturbances are indicating that they are still rising. So this means that Himalayas are still rising, being raised due to the compression and have not yet attained isostatic equilibrium. What do you mean by isostatic equilibrium? When this compression is stopped, that is called isostatic equilibrium. So the compression of the material between the plates are still going on. The mountains are still rising its height. So because of the various crustal disturbances, and recently we have found that some earthquakes are generated in the Nepal region. The earthquakes occurred in the Nepal region and leading to the death of the thousands of people. And also some of the disturbances, some of the earthquakes are generated in the Delhi. So that is also indicating the Himalayas rising. So often the earthquakes are occurring in the northern part of India. That is mainly because of the crustal disturbances beneath the surface of earth. Next one, the formation of the Alps, Urals and Appalachian mountains and Atlas mountains. They are also called, all are very similar to the formation of the fold mountains. For example, if you see, Alps mountains formed due to the convergence of the African plate and Eurasian plate. Here you see this is Alps mountains and convergence of the African plate and Eurasian plate. This convergence of the African plate and Eurasian plate, there, that is the reason behind the formation of the Alps mountains. The Atlas also for the same reason, conversion of the African as well as the Eurasian plates. Ural mountains are formed due to Europe plate convergence with the Asian plate. Europe plate convergence with the Asian plate. So this, because of the convergence of the Europe and Asian plates, Ural mountains are formed in the Europe. The next one, Appalachian mountains. Appalachian nothing but a series of mountains, a chain of mountains called Appalachian mountains, and very old mountains, and this happened due to the collision of the North American plate as well as the Europe plate. So these are some of the examples. These are some of the examples of continent and continent convergence. These are some of the examples of continent and continent convergence. So and last one, there is absence of volcanism but presence of earthquakes in the continent and continent convergence. When there is no volcanic activity along the convergence of the continent and continent, why? Because thickness of the crust. Thickness of the crust, continental crust, is about 50 to 70 kilometers, and the magma unable to penetrate this thickness of the penetrate into crust because of this thickness. So that's why there are no volcanoes in the Himalayan range. It may be Alps, it may be Ural mountains, Atlas mountains, Appalachian mountains. So but in the ocean continent convergence and ocean convergence, there is a continuously volcanic activity generated, but in continent and continent convergence there will be no volcanoes because of the thickness of the crustal plates. You know that ocean plates are the very thinner in nature, means 0 to 5 to 30 kilometers. So it is very easy for the magma to penetrate into very thinner plates, but it is very difficult to penetrate the thicker plates, that is continental crustal plates. So there are numerous number of slabs, crust smashing together, numerous number of slabs of crust means smashing together, and continent collisions, and these lead to the generation of the large earthquakes in the Himalayas and North Indian region and Kutch region. These are the best example. But the earthquakes are happened due to the crustal disturbances. So with this, we are ending the convergent boundary. So in this convergent boundary concept, we were dealing with the three types of the convergent boundaries. Number one, ocean convergence. Because of the ocean convergence, various island arcs and archipelagos are formed. In the ocean convergence, various island arcs, mean a series of islands would be formed, as well as the archipelago islands would be formed. For example, Japanese islands, Caribbean islands, and Philippine islands, as well as the Indonesian islands. These are the best example for this ocean and ocean convergence. In the continent ocean convergence, various continental arc would be formed, means various mountain ranges would be formed along the margins of the boundaries. For example, Rockies and Andes, these are some of the best fold mountains that are formed due to the ocean and continental crust. So instead of the island arcs, continental arcs would be formed, a series of mountain ranges. But in the continent and continental convergence, another type of the fold mountains would be formed. For example, Alps mountains, Atlas mountains, Ural mountains, and Appalachian mountains, and one of the best example is Himalayan mountains. So with this, we are ending convergent boundary, and next class we are going to discuss about the divergent boundary, how seas and oceans would be formed due to the divergent boundary.